What's up, guys? Welcome to my channel. Today I'm gonna talk about the computer science giant, especially the giant of programming called recursion. Recursion is written is basically the process. This is the process of like this one. This is the process of repeating the same items in a similar manner, but in smaller inputs. Before we delve into the topic, please subscribe my channel and turn on the notification for the latest updates and videos. Okay. Now let's define the recursion. What's basically is the recursion and how it is done. So it is done algorithmically or abstractly. Abstractly mean way to design solutions to the problems by divide and conquer or decrease and conquer. For example, there is a larger input like this one, and we break the problem apart into smaller subproblems like this one. This is the problem, and we broke it like this one. Into smaller subproblems. This is the big problem, the larger problem, and these are the smaller versions of the same problem. So this is called recursion. If we think of it as in abstract manners, but programmatically or semantically, we come here. This is basically the programming technique where a function calls itself again and again until the base condition meets. Base condition means the base condition meets up to certain points. The base condition meets like this if some value like n is based on one or two inputs, and this certain condition means we return some value over here, okay, until the base condition. So semantically we think of the recursion as a programming technique of a function which calls itself again and again until into smaller inputs until the base condition meets. Base condition meets mean the recursion should not be infinite. There is no infinity. At some point like this, the program stops. Okay, so the second point of semantic definition of recursion is like simplifying the larger problem input. It must solve the same problem by some other input. which should be our goal. The goal is to simplify the larger problem input. So this is the larger problem input, and we turn this larger problem input into some smaller input like this. For example, here is n at the root node, and we break it and make it small enough. N minus 1, n minus 2, n minus 2 here, and decrease it by 1. The same function is decreased. The input n of the same function is decreased by 1 here, n minus 3, n minus 3, n minus 4, until base condition. After this, the function, the recursion stops. So this was a definition of recursion. It was simply the definition of recursion. We will get back to the examples in the meanwhile. But for understanding the recursion, realistically, we should know about the iterative algorithms. What is algorithm? Like looping construct, for, while, do while. These are the loops. But in these loops, there are some variables which are called state variables, like while I is greater than 0, I plus plus. This I, this is called the state variable. Which is used to show the current condition of loop or program execution. So this was it. Let's first start from iterative algorithm and see it in concrete form, like a program. For example, multiplication. Multiplication, which is basically the function that multiplies with itself or another number. For example, A is one number and it multiplies with B, another number. For example, like this one, 2 multiplies by 3. Do you understand? So how can we how can we build a program that is the version of this multiplication using iteration? So iteratively we can write it like, this is B times A. B times A, or A times B. We can write it like A plus A plus A plus A dot dot plus dot dot plus a. For example, we can this is 1a, this becomes 2a here, this becomes 3a, 4a, na. We can write it like this: 1a, 2a, 3a, 4a. These are 4a's and are the same numbers. B times plus na. So we can write it like this: a plus a multiplied by b minus 1. A times b minus 1. A is drawn outward, so b minus 1. So is equal to a times b. Okay, and this is the same as a plus a. We can write it like this: plus a times b minus 2. It's like inductive process. We can write it so it becomes like a plus a 2, a plus a times b minus 2, or 3a, or we can write it same as 3a plus a times b minus 3 up to na plus a b minus a times b minus n. Yes, so you know what's this? These are the inductions, mathematical inductions, and they are proved to be the recursive calls. So let's go with the writing a simple program of multiplication using iterative approach. Then we come to our topic in discussion, like the recursive. So we will turn that iterative code into recursive code. So we have to go on buddies. For example, there is a function like which returns integers. Integer means the result of multiplication, and this is a mult function, and it has two arguments like int a and integer b. So what we do with this: if a is equal to 1, return if b, we can write it b here and a here. Then if we write here a, then we return here b. But if we write here b, we return here a. So we return a here. So this is like else if b is not equal to 1, what we have to do? We have to use like or we can say like this: if this is our iterative algorithm, we can write it like this. So sorry for that. While b is greater than 1, int result is equal to 0. We declare a variable which stores the results data. Result is equal to result. The previous value is the stored value is immediately adds up with this argument a. Then it's stored until the loop condition becomes true. So then what we have to do, we have to minus it like b minus minus. So this is a basic concept of iterative algorithm that is treated like a recursive algorithm. But immediately we will convert this code into recursive code to understand recursion better. So did you get it? I'm sure we have to return the result for calling it in the main function. So we have to write it here, int result is equal to 0. So return result. So it will calculate like, here is 3, there is 4. 3, 4. While 4 is greater than 1. Yes, this is greater than 1. So result is 0 here because we initialize the result with 0. What do we have to do? 0 plus a is 3. 3 is added here. Then it becomes 3. 3 is greater than 1. Yes. What is stored in result? 3. 3 plus 3. 6. R is result is 6 now. So now it's 2. You have to iterate it again. 6 plus 3, 9. Now 1, it becomes 1 from 2 because we are subtracting the b here. So 1 is greater than 1? No. So equal to 1. Okay. Yes. Yes. Now greater than or equal to 1. So 9 plus 3. The fixed value is a for a. The result has variation because it is adding up its value again and again using this while loop. So the result is 9 plus 3, 12. 12. So 4 3s are 12. Then it becomes not 1. It becomes 0. So 0 is greater than or equal to 1? No. So the loop terminates and the result is returned. So this was a simple problem of understanding the iterative approach for recursion. Now we have to convert that recursive code into iterative code into recursive code. So here it comes, int mult integer a int b if b is equal to 1, return 1, else return. Now we will use recursion by calling the same function or the same version of the main problem in smaller input like return a plus mult. This function is recursively called in the same function. This is the same function block, and here during else condition, when it meets, we are returning a plus, with which a is same because it is not changed. This argument is written as it is, but b is -1 is changing, so it will call itself again and again, adds it with this. So the frames are created here, the smaller frames, and they are added up with a. So what it becomes of like the same problem like iterative version of the problem, but here we are specifying it using the this problem using the recursion. So like it's 2 and it's 2. B is equal to 1. No, b is not 1. B becomes 1 when it becomes so smaller that it meets this condition. Understand? So here the else condition is called, here is 2 plus mult b minus 1. B minus 1 means 2 plus 2, so 2 plus 2 is equal to 4. Now b minus 1, it was 2, it becomes 1. B is equal to 1, return 1. So returned, the result returned is 4. 2 2s are 4. I hope you understand this problem. So we are going to the next topic in the next video. For now, goodbye, take care.